Hello everyone, welcome back with another video that is based on statistics. And this statistics is based on specifically for S2, and it is useful for Edexcel as well as Caie, that's Cambridge Curriculum. So first I would like to explain important notes and then I will discuss one past paper. So let me clear with you guys, this topic or this whole video is specifically based on Edexcel curriculum, but it is as useful as Edexcel paper for the Cambridge as well. So I will request you to just go through whole video if you are Cambridge student, and if you are Edexcel, then of course you should watch this whole video to revise full statistics in a very short period of time. So first topic I have covered that binomial distribution. So in the binomial distribution, you know that if a random variable x has the binomial distribution b n comma p, n is the number of trials and p is the probability of success, then its probability when p of x equals r is ncr p to the power r and 1 minus p to the power n minus r. This is actually q. So you know that q equals 1 minus p, right? And the mean of binomial distribution, that is ex, that is expectation, which is mu equals np, and the variance is npq, npq, and the q is 1 minus p. So np 1 minus p, that's variance. And if you need to find a standard deviation, that is root of variance. Now I'm going to deal with the Poisson distribution. So that is Poisson distribution. First of all, I would like to explain about binomial distribution that is based on discrete variables like number of people, we can say, or any number which is countable like 1, 2, 3, 4, 5. Okay, this is not continuous. Poisson distribution is also discrete, but the difference is it will be, for the duration of the interval, like time interval or any space interval. So that's when it is about the interval, then we need to use about the Poisson distribution. In this Poisson distribution, first of all, presentation is PO, and then this lambda. This is very important here. This is called actually mean. The Poisson distribution is given by P of x e to the power minus lambda, lambda to the power x over x factorial, and x can be 0, 1, 2, 3, 4, 5. For example, you need to find P of x equals suppose 5. Then you will write e to the power minus lambda and lambda to the power 5 over 5 factorial. Lambda will be given to you. And if x distribution, which is Poisson, and the p of lambda, and y is another Poisson distribution, p of mu, then x plus y is p of lambda plus mu. That's it. Just the lambda will be addition of individual these two lambdas. And now we are going to learn about mean and variance for the Poisson distribution. So p of lambda is the mean itself, and the variance is also lambda. So in this case, if you observe, then Poisson distribution is having mean and variance same, that's lambda. Now approximation, we need to approximate the Poisson distribution and the binomial distribution according to some rule. So if binomial distribution has n large and p is small, then this x can be approximated by Poisson distribution where lambda is np. You know that in mean, see in Poisson distribution, this is your mean, right? And how will you find mean from here? Np. If you do np, then you can get mean. So lambda is np, that's it. But the condition is if n is large and p is small, then you have to convert in Poisson distribution. But if n is large and p is close to 0.5, then binomial distribution is converted to normal distribution where mu comma sigma is square. And we have one more rule over here. When n is large and p is close to 0.5, then you can use then you can convert binomial to normal distribution, or np, if np is less than 5 and nq is less than 5. If these two are less than 5, then also you can use normal distribution. But we know that in normal distribution, mu is np from binomial and the sigma square, like variance, is npq. Since binomial distribution is discrete distribution but normal distribution is continuous, so while using normal approximation to binomial distribution, we need to apply continuity correction. Of course, like if you are converting Poisson distribution to normal distribution, or binomial distribution to normal distribution. So there is a difference between these two distributions. Normal distribution is based on continuous variables like height or weight. Like the height can be 5.1 inch or 5.2 or 5.3 or 6 also, right? And weight can be 5 kilograms, 5.1 kilogram, 5.9 kilograms, like that. So decimal is also valid over here. But if binomial, if you are going to convert in normal, then we have to do continuity correction as well. For example, p of x is greater than 5. So p of x is greater than 5, then think about the next integer of 5, which is 6. Then take average of 5 and 6, which is 5.5. X equals 9. So it will come in the middle, subtract 0.5 and add 0.5. You will get this. P of x less than equal to 3. So you can write this as p of x less than equal to 3. You can write p of x less than 4. So in binomial, p of x less than 4 and p of x less than equal to 3, both are having same meaning. Now just take average of these, which is 3.5. P of x less than 3, it means p of x less than equal to 2. And then take average of these two, which is 2.5. P of x greater than 5. This is p of x greater than 4 in binomial. Greater than 4, greater than equal to 5, both are same. So take average of these two, which is 4.5. In normal, in binomial, if there is no equality here, and if there is equality, there is some difference between these two. But in continuous, if there is equality and there is no equality, both are same thing. For example, this is normal, so I can write this p of y greater than equal to 5.5. Doesn't matter, because this is normal, this is also normal, because it is continuous, right? So it doesn't matter. Now in Poisson distribution, lambda is, now we are going to convert even Poisson to normal, but there is some case. If lambda is very large, then this Poisson distribution also can be converted to normal. But you know that for the normal distribution, we need to convert, then this is mu comma sigma square, right? But you know that in Poisson, mean is also lambda and variance is also lambda, both are same. So lambda comma lambda you will write. But for this course, lambda should be greater than 10, then only, right? Lambda is large, so lambda should be greater than 10, like 50, 100 something. But if lambda is 9 or 8, so this is smaller than 10, then we should not convert to the normal. We should proceed ahead with the Poisson distribution concept to deal with the questions. Now here I have made one chart which is about the approximation. So first is binomial. This binomial is converted to normal when n is large, p is close to 0.5, or you can say np is less than 5 and nq is less than 5. If these, see, this meaning and this meaning both are same. If n is large, p is 0.5, then np is less than 5, then you have to use continuity correction, or I mean first you have to convert to normal approximation. And if nq is less than 5, then also you can proceed with the normal distribution concept. Hello guys, we need to do some correction over here. Like this condition I told np is less than 5 and nq is less than 5. So actually it is np is greater than 5 and nq is greater than 5. So we have to erase this. Okay, so now we have either n is large and p is 0.5, then you can approximate this binomial to normal, or np is greater than 5 and q is greater than 5. Okay, so similarly we have to do correction over here as well. Yeah, at this place. In this case, same thing I wanted to tell. np should be greater than 5 and nq should be greater than 5. Then we can convert binomial to normal. Okay, now now we are here. Binomial, how when we will convert to Poisson? If n is large, binomial when n is large and p is a small. Okay, over here n is large, p is 0.5, or np or nq greater than 5, then normal. But here n is large but p is a small, then you have to write lambda, Poisson distribution p of lambda. But Poisson distribution also needs to be converted in normal when lambda is very large. Okay, and with the continuity correction we know that. continuous random variable. So a continuous random variable we need to understand. First, I'm going to explain with the help of discrete example. Let us understand with the help of discrete random variables. Toss the coin 10 times. Number of head we need to count. This will be a discrete random variables. So suppose x is okay. If you toss your coin 10 times, then definitely you can have your head either 0 number of time or 1, 2 or maximum 10, but not 11 number of times head will come because you are tossing 10 times only. So distribution table, you will write, this is the distribution table. So x 0, 1, 2 to 10, and p of x 10 is 0, half to the power 10. This distribution table you can form. How you will form, just I will explain you. P of x equals r is ncr p to the power r q to the power n minus r, right? So over here probability of head is half, and that not head like q, p is half and q is also half. 1 minus half is again half, and this is 10c0, n is 10. So here this is 10c0 and half to the power 0 and half to the power 10 minus 0. So basically 10c0 half to the power 10, which is this. Now again here 10c1 half to the power 10. How? This is 10c1 half to the power 1 and half to the power 10 minus 1, right? Just you will add up, you will get this. So just calculate, you will get this table. Now I'm going to plot these over here. Okay, so please try to understand. This is your discrete random variable, this side like 0, 1, 2, 3, and this side I have plotted, this side I have plotted probabilities. So when x is 0, this is the probability. When x is 1, this is the probability. So when you observe, then you will find this probability. Okay, this probability, this one is equal to this one, and this one is equal to this one, 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 and the middle one is the highest one. So see, this is here. When you get this, you will get this. 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 So that's why it is symmetrical about middle one. So this is your mean. Okay, so these are discrete. Okay, one point, another point, another point. But if you join all these points by your smooth curve, then you will get this curve, right? And this curve will give you this is the discrete random variable, but this curve will give you continuous random variables curve. Okay, if we join all points with free hand, then we can get the graph, and we observe closely. This graph can be graph of continuous random variables, and this graph is called probability density function. Yeah, this is a function. This is y is equal to PDF, probability density function. It means with the help of PDF, we can get probabilities of all points variables, whether that is integer, decimal, or any number. Like this is your point. So these are decimal one, but sorry, these are the integer one. But with the help of this graph, we can find the decimal probability as well. For example, here, then you can find this. For example, here, then you can find this. Okay, if x is a continuous random variable with probability density function fx, then some properties. F of x is greater than or equal to 0, like your probability density function should be above x-axis, like this. And if you need to find the probability, then just we have to integrate from a to b. And when you integrate from minus infinity to plus infinity, then it is always 1. Like suppose when you have this curve and you are going to integrate from here to here, then this complete area is 1. For a random variable x, the cumulative distribution function CDF, which is f of x, which is p of x less than is equal to small x. Like see, this is probability density function. Okay, PDF is probability density function, and CDF is the probability. It's a cumulative density function, distribution function, but it's actually a probability. It's a integrated part. So f of x, like if we need to find f of 10, it means p of x less than equal to 10. It means suppose this is the curve, then f of 10 means we have to find this whole area. Okay, so minus infinity to 10. So CDF is minus infinity to x, PDF just okay, p of x less than x minus infinity to x. So CDF is capital F of x, PDF is a small f of x. This is a standard way. Capital F of x minus infinity to x f of t dt. This is your CDF. And f of x, suppose you need to find like probability density function you need to find, then you have to differentiate your CDF. It means if you integrate PDF, you will get CDF. Okay. And if you differentiate CDF, you will get PDF. So same thing I have explained here. PDF integration is CDF, CDF and differentiation is PDF. If x is a continuous random variable with PDF probability density function fx, then mean is mu, which is minus infinity to infinity x f of x dx. Variance is sigma square, which is x minus mu whole square f of x, or you can say x square f of x minus mu whole square, minus infinity to infinity. It is similar like in AS level, which when we have learned about finding variance, when over there it was x square f minus minus mean whole square. So similarly, instead of x square we have x square, but instead of f here it is probability density function, over there it was frequency. Now e of gx is minus infinity to infinity gx fx. For example, e of for example, I need to find k cube, then I will write minus infinity to infinity. This is k cube, so k cube will be here and fx will be there. Okay, so variance is e of x square minus e of x whole square. Why? Because you can check this one. This is e of x square and minus mean whole square. So same thing. E of ax plus b, this a will go outside, a of ex plus b. And when you need to find variance, then this a will be a square variance of x, and there is no effect of b. Mode of, and one more thing, you guys might be thinking that I am explaining very fast, because this video is basically for the quick revision of S2 for the exam point of view. So this video is useful only when you have some concepts. This is not for a learning point of view from the scratch. This is just for the exam revision. This is not for learning perspective. It is only for the revision perspective. Mode of continuous random variable is the value of x for which PDF is f of x maximum. So we know that already, when the mode is the highest repetition. So over here you will get mode for that value of x for which probability is maximum. For example, we have this, so this will be our mode because here the probability is max. If x is a continuous random variable with CDF is equal to capital Fx, then medium of x is the value of m such that f of m is 0.5, like half. Okay, the lower quartile is f of q1 is 0.25 and upper quartile is f of q3 is 0.75, and nth percentile of Pn is the value of a such that f of a is n over 100. Continuous uniform distribution. Random variable having a continuous uniform distribution over interval AB has this PDF. For this is the PDF. Okay, this is PDF 1 over b minus a to b. This is just for the continuous uniform distribution, right? Uniform, it will be a straight line a to b. So now the function is already given 1 over b minus a, so just subtract 1 over b minus a, you will get this, and 0 otherwise. So only this is the function. If x has continuous uniform distribution over the interval AB, then this is represented as x, and distribution is u. AB, u means over here this one, continuous uniform distribution. Okay, this one. Now ex is a plus b by 2, variance is b minus a whole square divided by 12, and this is CDF, which is 0, x minus a over b minus a, and 1. So here it's directly written. Okay, but actually we can derive this. So I'm just deriving for ex because it is simple, otherwise the rest will take time. So we know that expectation, right, minus infinity to infinity. So over here it will be x and f of x, right? So now minus infinity to infinity, but here we have only this side nothing, this side nothing, only a to b. So we will write a to b and x here, and this is function, right? This is function. So I will say fx is 1 over b minus a. So 1 over b minus a dx, right? Okay, so bx 1 over b minus a I will take outside. X integration is x squared by 2 and a to b. So e of x, first I will write b square minus a square over twice of b minus a. Okay, then e of x up will be b minus a times b plus a divided by 2 b minus a. You can cancel, and ex will be b plus a divided by 2. Okay, so see, a plus b divided by 2 ex. So if it is uniform distribution, then simply you can write ex as a plus b divided by 2, variance is b minus a whole square divided by 12, and f of x is, when x is less than a, is 0, and otherwise x minus a over b minus a. See, x in the middle, a to b, so x minus a over b minus a, easy to remember. And when x is greater than b, then it is 1. Last is always 1. Okay, sampling and sampling distribution. In statistics, the population is a whole set of items that are interest. Information can be obtained from the population. This is known as raw data. But census observes or measures every member of population. Census is observing every member, but sample is different from the census. Sample, just we are selecting some people or some elements, some data. For the research point of view, a sample is a selection of observation taken from the subset of population which is used to find out information about the population as a whole. Individual units of population are known as sampling units. Often sampling units of population are individually named or numbered to form a list called sampling frame. Yeah, this is important. Any characteristics of the population which is measurable is called population parameter. Yeah, this is very important. Any characteristics of a population which is measurable is called population parameter. For example, population mean and the population variance are the population parameters. So mean is, we know that sum of all elements divided by n, variance x minus mean whole square divided by n minus 1 are statistics. Why this is statistics? Because this mean or this mean which we have used here, this mean is not the mean of whole population. This is the mean of, I will say, this is the mean of sample data, right? But here xi minus mu whole square over n minus 1, this is also mean, right? But this mean is representing whole data. Okay, so x bar is the mean of sample data, and this whole is the, actually this is your estimated mean. Okay, this is not exact mean, this is estimated mean. So xi minus mu whole square over n. So now this is a statistics. Why this is a statistics? Because this is exact value of mean for the sample. Okay, but xi minus mu whole square over n minus 1 is not, because it involves the population parameter mu. Okay, population parameter mu. So this is not statistics. This is a population parameters, that's mu. Now, sampling distribution of statistics gives all value of statistics and the probability that each would happen by chance alone. A statistic has a sampling distribution that is defined by giving all possible values of statistics and probability of each. This is simple. Hypothesis testing. Hypothesis testing is in statistics refers to analyzing and see, first of all, this hypothesis testing is done on statistics, not on this population parameter. We will check for the population parameter whether it is valid or not. So hypothesis testing is basically tested on statistics, which is based on samples, and then we will generalize whether this result is valid for whole data or not. So we will see later. Hypothesis testing in statistics refers to analyzing an assumption about population parameter. It is used to make an educated guess about an assumption using statistics. With the help of use of sample data, hypothesis testing makes an assumption about how true the assumption is for entire population from where the sampling is being taken. Any hypothetical statement we make may or may not true need to provide evidence for either true or false. So here we have to when we initially assume that this assumption is true, then either we will not conclude that our assumption was right. We will either tell there is enough evidence to reject that assumption, or there is not sufficient evidence to reject that. Okay, it means whether that is true or not you cannot say, but you cannot reject, or you can reject that. The result of the experiment or statistics that is calculated from the sample is called test statistic. Null hypothesis is the beginning, like information which you're assuming needs to be true. Null hypothesis H0 is the hypothesis that is assumed to be correct. Alternative hypothesis tells about the parameter if assumption is shown to be wrong. Hypothesis test with alternative hypothesis is H1. H1 represent alternative hypothesis. P is less than something. Okay, this probability is less than something, or it is greater than something. It is called one-tail test. But hypothesis test with alternative hypothesis in when P does not equal to something, then it is two-tailed test. Okay, left side also and right side also. First, we need to assume the null hypothesis is true. If likelihood or a probability is less than given threshold or significance level, then reject the null hypothesis. Then we have to reject the null hypothesis. We will check with the help of calculations. In general, significance level is either 10%, 5% or 1%, or it will be given in the question. If likelihood or probability is greater than given threshold or significance level, then there is insufficient evidence to reject H0 or null hypothesis. Critical region is a region of the probability distribution which, if the test statistics falls within it, okay, would cause you to reject the null hypothesis. So it means we have to reject the null hypothesis, right? So suppose from here to here it is critical region. So if our value comes here, okay, under critical region, then we can reject, or you can say that it is less than significance level. So significance level is this. If it is coming over here, then obviously it is a smaller. So critical region is a region of the probability distribution which, if the test statistics falls within it, would cause you to reject the null hypothesis. The critical value is the first value to fall inside the critical region. Okay, so this is the critical region. This initial value will be the critical value, first value. Acceptance region, the region where null hypothesis is accepted, like this side. It is acceptance region. The actual significance level of hypothesis test is probability of incorrectly rejecting the null hypothesis. For two-tailed test, there are two critical regions at the each end of the distribution. One-tail test, method 1, to check hypothesis test. Step 1, formulate a model for the test statistic. Step 2, identify suitable null and alternative hypothesis. Calculate the probability of the test statistic, taking the observed value, higher or lower, assumption, null hypothesis. Like here it is telling that we have to find the probability of test statistics, and if probability is less than significance level, then we will reject the null hypothesis. If probability is greater than significance level, then there is insufficient evidence to reject the null hypothesis. And second, finding critical region and check if the observed value of the test statistic lies in it. If it lies in that, then we have to reject. If it does not, then there is no sufficient evidence to reject. For two-tailed test, half significance level at end of the testing. For two-tailed test, critical region is also split at the either end of the distribution. Okay, so this is whole in just 30 minutes or 29 minutes I try to cover full S2 revision, quick revision. Now I'm going to apply all those concepts in Pearson Edexcel paper, that is the past paper. The code is WST0201 and this is S2. So here also I will not take too much time. Already I have written solution, just I need to explain that. The independent random variable W and X have the following distributions. This is your Poisson, we know that. This is binomial. Write down the value of variance of W. We know that variance of Poisson distribution is lambda, right? So that is 4 only. Determine the mode of X. So for this we need to find one distribution table, and see this is 3 and 0.8. This is 3 and 0.8. So x equals r can be 0, 1, 2 and maximum 3 because n is 3 only. I'm trying to find probability for all cases, but again I will revise. P of x equals r is NCR p to the power r q to the power n minus r, right? So here tends is 0, p is 0.8. This is given, p is 0.8. So p is 0.8 to the power 0 and the q will be 0.2 to the power 3. Similarly, just put all these informations and get probability here. So now the maximum probability I'm finding, this one, 0.512, and it is for x equals 3. So here same thing I'm trying to explain. So probability is a maximum when r is 3, so mode will be 3. One observation from each distribution is recorded as w1 and x1. Find p of w1 and x1, and means multiplication. So p of w1 and p of w1 equals 2 and x1 equals 2. So and means simply multiplication. P of w1 equals 2. So w1, this is for Poisson. We know that e to the power minus lambda to the power x over x factorial, right? So lambda is 4 here. You can just check. Lambda is 4, right? So lambda is 4. So e to the power minus 4 and lambda to the power 2 over 2 factorial times out of 3 2 when x is 3, n is 3. So 3c2 p to the power 2 q to the power 3 minus. So just calculate everything by using calculator. You will get 0.056. Okay, now next part is this. Find p of x1 less than w1. So p of x1 less than w1, but what is w1, what is x1, it is not mentioned, but p of x1 is less than w1. So we have to make some cases. P of x1 less than w1. So p of x1, x is based on, please check, x is based on, see, x is based on binomial. So if x is based on binomial, so x1 can be 0. So 0 to maximum 3, right? So accordingly, we can say x1 can be 0, but w1 is greater than x1. So w1, if x1 is 0, then w1 should be greater than 0. Similarly, x1 can be 1, then w1 will be greater than 1. x1 is equal to 2, w1 is greater than 2. x1 is 3, then w1 is greater than 3. First of all, we have to check for this marks or 4 marks. So it's okay, good. Now p of x1 equals 0. So this is binomial. Okay, p of x1 equals 0 and p of w1 is greater than 0. This is for Poisson. So we can write 1 minus w1 less than equal to 0, because we know that for table is available when less than equal to 0 case is there. So now p of x1 equals 1, which is here, then times p of w1 is greater than 1. So 1 minus p of w1 less than 1. Similarly 2, 1 minus p of w1 less than equal to 2, then 3, 1 minus, okay. Now p of x1 equals 0. Here we can use calculator, or simply already we found here, right? We found here this one. When p of x 0, then it is 0.081, then so we will not to calculate again. I will use 0.008. Yeah, here 1 minus p of w1 less than equal to 0. So 1 minus, and this one we can find from the table, w1 less than equal to 0. So our value is 0.0183. Use Poisson distribution table. So I will check that. I will show you how to see Poisson distribution table. So p of w1 less than 0. Okay, so p of w1 less than 0. P of w1 is less than 0. P of w1 is less than equal to 0. And what is lambda? Lambda is, this is lambda, right? So what are lambda for our question? Lambda was 3. What was lambda? Lambda is 4. lambda is 4 and this is 0. Okay, lambda is 4. Yeah, here lambda is, see, please check here, lambda is 4 and when x is 0, so p of x less than equal to 0, so this one 0.0183. So 0.0183, 0.0183, 0.0183. Okay, 1 again I will show. This is 0.096, which is p of x1 equals 1, which is from here, 0.096, and p of 1 minus w1 is less than equal to 1. So 1 minus w1 is less than equal to 1. So 1 minus 0.091. So I need to show this. Less than equal to 1, lambda is 4. Okay, lambda is 4 and 1. Lambda is 4 and 1. Yeah, 0.0916. And next will be 2381. And next will be 4335. So please check 0916, 2381 and 4335. Okay, so just calculate everything, you will get 677. Now next, the time in minutes is spent waiting call for a call to call center to answer is modeled by random variable t with probability density function. This is given to us. Use algebraic integration to find in minutes and second mean waiting time. So integration of minus infinity to infinity, t f of t. Yeah, t f of t, minus infinity to infinity, but in this case we have 0 to 4 only. So t f of t, t is here, and f of t is already given 1 over 192 t cube minus 48 t plus 128, right? And now 1 over 192 you can take here and take t inside the bracket, t to the power 4 minus 48 t square 128 t, and integrate. So t to the power 5 over 5, which is integration of t to the power 4 minus 48 t cube over 3 128 t square over 2, and take value 0 and 4. Now take upper limit, which is here, minus lower limit, which is here. Use calculator. You will get 16 over 15 minutes. So you can add 1 minute plus 1 over 15 minutes. So 1 over 15 minutes, just multiply by 60 only for this case to get in seconds. So 1 minute and 4 seconds is the answer. Now next question says, show that 1, 2, 3 is 7 over 16. So simply integrate this part between 1, 2, 3 only. So it's again simple question. So integrate 1, 2, 3 f of t. So 1, 2, 3, 1 over 192, and this is your f of t, right? So 1 over 192, simply integrate t to the power 4 over 4 and minus 48 t square over 2 and 128 t. Put 1 to 3 limit. This 3, when you put inside, this will give you upper limit. Then minus, when this 1 you put inside, it will give you lower limit. And just calculate carefully, you will get 7 over 16. Now a supervisor randomly selects 256 calls to the call center. Use suitable approximation to find the probability that more than 125 of these calls take between 1 and 3 minutes to be answered. So 1 to 3 minutes, so P is already 7 by 16 and the Q will be 1 minus 7 by 16, which is 9 by 16, right? And you can say a supervisor selects 256 calls to the call center. So I think in binomial way we can write 256 comma P. Let's check what is there. Yeah, so n comma P, where x is the number of calls, n is 256, P is 7 over 16, and since n is large and P is near to 0.5, then we can use normal approximation, right? But we can use even this result also. NP is greater than 5 and NQ is greater than 5. If these two are valid, then also we can use normal approximation for this binomial. By the way, we are using n is large and P is 0.5. So 7 over 16, if you check 7 over 16, it is 0.4375. Okay, so but here there is a confusion. 0.4375 is near to 0.5 or not. Some students will tell that it is less, also it is about 0.4. So what should we do? So basically I prefer this one. NP is greater than 5 and NQ is greater than 5. So let's check what is NP. So can we find NP, guys? 256 times 7 over 16. So 256 times 7 over 16, which is 112, which is greater than 5, but it is not enough. Okay, we have to find NQ as well. So NQ is 256 times 9 over 16. We found Q here. Yeah, 9 Q 9 over 16. So NQ is how much? 256 times 9 over 16. This is also 144, which is greater than 5. Okay, so what we concluded? We concluded this is greater than 5. So NP is greater than 5 and NQ is also greater than 5. So we can say we can use normal approximation. But for normal approximation, we need mu and we need sigma square. So NP, N is this, P is 7 by 16, 112. And we know that NPQ we need to find. So N, P, and this is Q, which is 63. So this is binomial, N comma P. And it became now normal approximation, mu comma sigma square. Mu is 112 and sigma square is 63. So now same question became in normal. But one thing also we have to make sure, because we are talking about number of calls, right? Number of calls was in discrete, because 256 calls or 255 calls, it cannot be 255.5 calls. But we are using normal approximation, and we know that normal approximation is basically used for the continuous data. So we have to use continuity correction as well. Since binomial is discrete and normal continuous, so we have to use continuity correction. That's nice. More than 120, probability of more than 125 calls between 1 and 3 minutes. So P of X is greater than 125. So this is greater than equal to 126 also, right? Because greater than 125 means it will start from 126. So take average of these two, 125.5 you will get. This is called continuity correction. Now after that we have to use Z equals X minus mu over sigma to convert in normal. So P of X greater than 125, which is P of X greater than 125.5. And now Z is X is 125.5 minus mu 112 over sigma, which is sigma square was 63. So sigma is root 63. Okay, just calculate this part, you will get this. P of Z greater than 1.7. So when it is Z, you know that always we have to write in 1 minus, because left side result is available. So 1 minus P of Z less than equal to 1.7. And now this part we have to use this normal distribution table. So now I'm going to use Z value 1.7 to get this P. So Z is 1.7. Okay, come down. Z is 1.7. Z is 1.7. This is normal. 1.7. 9554. 0.9554. 0.9554. 0.9. Yeah, 0.9554. So just subtract, you will get 0.0446. So finally, P of X greater than 125 is 0.0446. It means, yeah, find the probability. So the probability we found, that is for more than 125 calls out of 256 was possible between 1 and 3 minutes, which was answered. Okay, now come to the next question, which is question number 3. A point is to be randomly plotted on x-axis, okay, where the units measured in centimeter. The random variable r represents the x-coordinate of the point on x-axis, and r is uniformly distributed over -5 and 19. Okay, yeah, here this is x-axis. Okay, this is -5 to 19. Okay, next is a negative value indicates the point which left side of origin, and that's understood. Now find the exact probability the point is plotted to the right of the origin. Okay, so first of all, this is PDF will be 1 over b minus a. So 19 minus of minus 5, which is 24. So here I will say f of x is 1 over 24. But right of x-axis like positive only this. So we have to find what we have to find the exact probability. It means area. We have to find this area, right? So this length is 19 and this length is 1 over 24. I have written 1 over b minus a to be okay, that's fine. A part, right to the origin. So this length is 19 and height is 1 over 24. So 19 times 1 over 24, 19 over 24. Next says, sketch the cumulative, find the exact probability the point is plotted more than 3.5 centimeter away from origin. Okay, so this is origin, right? So 3.5 centimeter away from origin. So it can be in the right direction or it can be in the left direction. So 3.5, 3.5. So 7 length and height is 1 over 24. Same thing I've written, 3.5 centimeter away from origin means 3.5 centimeter left direction, 3.5 centimeter right direction. So probability will be 7 times 1 over 24. Why? Length is 7 and height is 1 over 24. So area will be 7 times 1 over 24. Okay, now the question was, find the exact probability the point is plotted more than 3.5 centimeter away from the origin. Okay, so here we found between 3.5 centimeter from the origin, but our question was away from origin 3.5 centimeter. So what was the main? Minus 5 to 9, right? So minus 5 and 9. So we have to find actually this area, right? So what we can do, we can find total area 1 and then we can subtract this part. So 1 minus, and this part already we found 7 over 24. So 1 minus 7 over 24, that is 17 over 24. Okay, next is, what is the next one? Sketch the cumulative distribution function. It is only for 2 marks, right? So we should not derive that. We should use this result. P of x less than a, then 0. When a to b, then x minus a over b minus a, and then when x is greater than b, then 1. So a is minus 5 and b is 19. So when x less than minus 5, it is 0. Now x minus of minus 5, that is plus 19 plus 5 and 1. So this is for 2 marks, so only we should write that. Otherwise, we can use concept of cumulative distribution function to find f of x. That also I did. Okay, that's just for explanation. P of x equals as P of x less than equal to x, which is minus infinity to x, f of t dt. So when x is less than minus 5, then nothing was there, right? When x is less than minus 5. Okay, should I draw one same thing here? Okay, minus 5 and 19. So over here fx is 1 over 24. So when x less than minus 5, then you have 0. So minus infinity to x. Okay, this is x, only x. So minus infinity to x, we have 0. And now everywhere we have to take, if we are coming to this region, then also we have to consider minus infinity to x. So minus infinity to x, but x lies between minus 5 to 19. So when you consider this, then first you have to write minus infinity to minus 5, this one, then minus 5 to x. So minus infinity to minus 5, the function was 0. And then minus 5 to x, like in this region, function is 1 over 24. And when x is greater than 19 means this side. So minus infinity to minus 5 to 19, and then 19 to greater. So minus infinity to minus 5 to 19, and 19 to x. So this side is 0. Here we have 1 over 24, and here we have 0. Now just calculate that. After that, just calculation. This part will give you 0, this part will give you 0, and this part will give you x plus 24, x plus 5 over 24, and this part will give you 1. Just calculate. So see, again I got this one. Now if you plot when it is minus 5 and less than -5 it is 0. So x-axis, now -5 to 19 it will be a straight line, right? So just join. At 19 it will be 1, and after 1 it is again a straight line. So our graph is something like that. This is a straight line, then this is a straight line. Okay, D part is saying, oh, C part was a sketch. Okay, 3 independent points with x coordinates r1, r2, r3 are plotted on x-axis. Okay, find the exact probability that all 3 points are more than 10 centimeter from the origin. All 3 points are more than 10 centimeter from the origin. So P of R1 greater than 10 centimeter, right? So 19 minus 10 over 24. Why? Let us again understand this. It's -5 and it's 19, more than 10 centimeters. So left side it is not possible, right? Only here it is possible. So only this part we can consider. So that's why 19 minus 10, this part length 19 minus 10, height is 1/24, we know that. So 3/8. Similarly, R2 will also cover in this region only. That's also R3 will also cover here, and these three are independent, right? So R1 greater than 10, R2 greater than 10, R3 greater than, these are independent, so just multiply 27.512. Now we have find the exact probability that the point furthest from the origin is more than 10 centimeter from the origin. The point furthest from the origin is more than 10 centimeter from the origin. Furthest. So the point furthest from the origin is more than 10 centimeter from the origin. Okay, what is the meaning? Let us understand. Let P be the probability for the point which is 10 centimeter from the origin, which is 3/8. Now, the point furthest from the origin is more than 10 centimeter from the origin. It means at least one point which is furthest, which is more than 10 centimeter from the origin out of 3 points. Okay, so out of 3 points, at least one point should be there. So 3c1 p to the power 1 and q to the power 2, 3c2 p to the power 2. This is 1 minus p to the power 1, 3c1. P is 3/8 and 1 minus 1 over 3, that's 2 over, that's 6/8. Just use calculator, you will get 3 or 7 or 512. Now, past evidence shows that 7% of pears grown by farmer are unfit for sale. And this season it is believed that proportion of pears that are unfit for sale has decreased. Okay, to test this belief, a random sample of n pear is taken. See, this is for hypothesis testing question. Past evidence shows 7% of pears grown by farmer unfit for sale. It's past. Okay, this season it is believed. Okay, we have to check whether this belief is right or not. Proportion of pears are unfit for sale decreased. To test this belief, random sample of n pears is taken. The random variable y represents the numbers of pears in the sample. Find the smallest value of n such that y equal to 0 lies in critical region for this test at 5% of significance level. To solve this question, we need to come here. The test statistic y represents number of pears in the sample that are unfit for sale. So null hypothesis is H0, which is p equal to 0.07. The probability of pears grown by a farmer are unfit for sale, which is given in the beginning, like 7%. And now alternative hypothesis, which is H1, p is less than 0.07 because it is assumed that the probability has decreased since the proportion of pears that are unfit for sale has been decreased, right? Now significance level is 5%, so 0.05, and y, which is b and comma p, n is not given over here, but p is given 0.07. Now according to the question, y equals 0 lies in critical region, right? So critical region, it means there is a rejection, right? There is a rejection of the belief. So y is equal to 0 lies in critical region. So when lies in the critical region, it means it is being rejected. And when it is being rejected, when the probability is less than significance level, all right? So y equals 0 out of this. So NC0, p to the power 0, 1 minus p to the power n minus 0 is less than 0.05 significance level. So this is 1, this is 1.93 to the power n. Now just either you can use log both sides, or you can just use hit and trial method to get a value of n when it is less than 0.05 to give you overall value. So I applied natural log both sides. Now I applied ln over here, then n will come to this side like here. So n times ln this, and now I found ln 0.93, which is minus of something, ln 0.05, which is this. Now when you multiply by negative number both sides, then this inequality sign will change, and now divide by this number. So you will get 41.28. so n just greater than 41.28, that is 42. Okay, or you can use it and trial, right? Just put n equal to 1, 2, 3. So when you put n is equal to 41, this value will be still greater than 0.05. But when you put n is equal to 42, this value will be smaller than this, so you have to consider 42. Now B part. What's the B part, guys? In the past, 8% of pears grown by a farmer weigh more than 180 gram. This season, the farmer believes the proportion of pears weighing more than 180 gram has changed. Okay, it is changed. So it was one tail because it was less, right? It was less. Decreased, right? So it is one tail. But now this season, farmer believes the proportion of pears weighing more than 180 gram has changed. So change means it can be high, it can be low. She takes random sample of 75 pears and finds 11 of them weigh more than 180 gram. Test using suitable approximation whether there is evidence of change in the proportion of pear weighing more than 180 gram or not. Is there change or not? So maybe there is a change. So we will initially we will assume that weigh more than 180. That will be our null hypothesis, and alternative hypothesis will be changed. So if there is rejection, then we will say, yeah, we have to reject our null hypothesis. It means way more than is valid, and not, then we will say we don't have enough evidence to reject our null hypothesis at 5% significance level. So let's start now. So B part says test statistics X represents the pear grown by the farmer weigh more than 180 gram. Null hypothesis will be 8%, right? So 0.08, and the probability of pears grown by the farmer weigh more than 180 gram. Alternative hypothesis, which is H1, which is does not equal to, this is two tails, P does not equal to 0.08, proportion of pears weighing more than 180 gram has changed. Okay, now testing 11 pears out of 75 pears. So N is 75 and P is 0.08, N is 75, P is 0.08, N is large and P is small. So we have to use Poisson distribution over here, right? N is large and P is small. When N is large and P is near about 0.5, then we use normal. But here N is large and P is small, so we have to use Poisson distribution. And for Poisson distribution, you know that we need to find lambda. So lambda is 6 right now. So we got this one. Now, according to the question, P of X is greater than 11. So we need to understand why 11. Can we read question again? Yeah, finds that she takes random sample of 75 pears and finds that 11 of them weigh more than 180 gram. 11 of them. So minimum 11, right? So here, so P of X is greater than equal to 11. So 1 minus P of X less than equal to 10. Now 1 minus P of X less than equal to 10. This value we can get from the Poisson distribution table when lambda is 6. So lambda is 6 and X is 10, less than equal to 10. Okay, lambda is 6. Lambda is 6, okay, and 10, this one, 9574, okay, 9574. Yeah, 9574. So P of X is greater than equal to 11 is 1 minus 9574, which is 0.0426. Now we have to compare with the significance level, which is 0, I think 5%, right? Can we check again? 5%. But as I told you in the beginning that it is two-tail, so this 5% will be divided in two parts, 2.5% left side and 2.5% right side. Since it is two-tail condition, so two critical regions, one at each end of the distribution, 2.5%. So let's compare 0.0426, which is our probability, and this is 2.5%. so our probability is greater than significance level. So significance, this probability is greater than significance level, right? So when it is greater than significance level, then there is, since likelihood of probability is greater than significance level, so there is insufficient evidence to reject null hypothesis, or you can say 11 does not lie in the critical region. Finally, there is not significant evidence to suggest that proportion of pairs weighing more than 180 gram has been changed. It means there is no sufficient evidence to prove or to say that weigh more than 180 gram has changed. Now, fifth one. The number of particles per milliliter in a solution is modeled by Poisson distribution with mean like lambda is 0.15. Randomly selected 50 milliliter as a sample. So per milliliter lambda is this, 50 milliliter lambda will be 50 times 0.15. Find the probability that exactly 10 particles are found and between 6 and 11 particles inclusive are found. So p particles 0.15, n is 50, so mean is 7.5 now. New Poisson distribution, p of 7.5, p of x equals 10 e to the power minus lambda, lambda to the power 10 over 10 factorial, and lambda is 7.5. Just use calculator to get the answer. 6 to 11. So since it is not 1 point, there are many, 6 to 11, so 6, 7, 8, 9, 10, 11. So instead, we can use this result. P of x less than equal to 11 minus p of x less than equal to 6. Now use chart or Poisson distribution table to get this value, and to get this value just take subtraction, you will get the answer. Now B part. Petra takes 12 independent sample of m milliliters of the solution. So m milliliters, so the lambda will be 0.15 m. Okay, the probability that at least two of these samples obtain no particles is this. Using a statistical table provided, find the value of m. Okay, so lambda or mean for m milliliters is 0.15 m. P is the probability which contain no particles. So P of x is equal to 0, no particle. E to the power minus lambda, lambda to the power 0 over 0 factorial, which is this. So probability is this, and at least two of these sample contain no particle out of 12 sample. So P of this is given to us. So P of x greater than equal to 2 is 0.1184. So 1 minus P of x less than equal to 1 when you have 0.1184. And now just shift this side and take this side. So 1 minus 0.1184 is P of x less than equal to 1, which is this. Now here you can check P of x less than equal to 1, which is 0.8816. Use table to get probability over here, right? We have to use table to get the probability. So P of x less than equal to 1, P of x less than equal to 1 is 0.8816. Okay, so now here P is 0.05. So this one we have to understand from where it will come. So 0.8816, and this is Poisson distribution, right? 0.8816. Okay, 0.8816, and 0.8816. p of x less than equal to 1. And 0.8816. X is equal to 1. 0.8816. So in this case, guys, we have to use binomial distribution. Binomial distribution table. Why? Because you can check here, at least 2 of these samples contain no particles out of 12 samples, right? So n is 12. So we have to check when n is 12 and p of x less than equal to 1. So n 12 and x equals 1, then p we need to find in binomial distribution. So come here, come down, and then binomial where n is 12. Yeah, n is 12 and p of x less than equal to 1, and the probability is 0.8816, right? Okay, so here what was p? P is 0.05. So p is 0.05. P is 0.05. So in this case, when this is the probability for the binomial, then p will be 0.05. But what was p when we found? P is e to the power minus 0.15 m. So minus 0.15 m is 0.05. Apply ln both sides. So here if you apply ln and here if you apply ln, then this will come down here. So minus 0.15 m is equal to ln 0.05, and then divide by minus 0.15, you will get 19.97. Okay, so this was a good question. So I believe this was a good question. Find the value of m. Now B part, no, we did that. Now sixth question, continuous random variable x has probability density function where k and alpha are constant. It is not given whether it's positive or negative, so we have to check. And the question, it is known that p of x less than 4 is 31/45. Find the exact value of k. Less than 4, so we have to find in this region and in this region. So probability, integrate 0 to 2 this part and 2 to 4 this part. Okay, it is for 4 marks. So let's check A part, guys. So minus infinity to 4 means 0 to 2 and 2 to 4. So 0.1 x square over 2 and k outside, and 8x minus x square, which is 8x square over 2 minus x cube over 3. Just put all these values. I got p of x less than 4 is this, and p of x less than 4 is 31/45. Just equate and rearrange and calculate k is equal to 1/60. Okay, so exact value. Now B part says here, find the exact value of A and find the exact value of 0 to 5.5. So when you integrate minus infinity to infinity, then answer is 1. So we have to use that concept here. Minus infinity to infinity fx is 1. So minus infinity to 4, 4 to 6, 6 to infinity, that is 1. So here minus infinity to 4, already we got 31/45. 4 to 6 fx is a, so a will be there, and 6 to infinity, that is 0. So here a is constant, 6 minus 4, and this part is 0 here already. Now this is 2a, and just take the right side, 1 minus this, 14/45, divide by 2, 7/45. So it's just a mathematics question. It's not a word problem, it's a simple one. Specify fully cumulative distribution function. Yeah, this is good problem. So you know that cumulative distribution function f of which is minus infinity to x, f of x dx. So simply we have to integrate, but we have to integrate in sections. So here, oh, we need to find for 0 to 5.5, just integrate 0 to 2, 2 to 4, and then 4 to 5.5. That's it. So I don't think it's a big task. Yeah, this one. Cumulative distribution function. When x is less than 0, then minus infinity to x, then 0 to 2, then minus infinity to 0, 0 to x, 2 to 4, then minus infinity to 0, 0 to 2, and then 2 to x. 4 to 6, it means minus infinity to 0, 0 to 2, 2 to 4, and 4 to x. And x greater than 1, then when x last one is always 1, so no need to write. It's indirectly you can write 1. And after that, just integrate. This is 0, this is 0, this is 0.1 x square over 2, 0 to x, right? So just I did calculation over here. You can pause the video and you can try to understand. So now just put these limits, okay, to get these values. Now solve further to get this value, and finally this is your answer. Okay, so you cannot memorize it. It was for 6 marks. You have to write all these things. Now question number 7, that says a bag contains 10 counters, each with exactly one written on it, with exactly one number written on it, sorry. There are 6 counters with number 7 on it. There are 3 counters with number 8 on it, 1 counter number 9 on it. A random sample of 3 counters is taken from the bag without replacement. These counters are then put back in the bag. This process is repeated until 20 samples have been taken. The random variable y represents the number of these 20 samples that contain counter with number 9 on it. Find the mean of y, find the variance of y. So y represents number of these 20 samples that contain the counter with the number 9 on it. So y is equal to r, and r will be 0. Out of 3 counters, no one is number 9. 1 means r is equal to 1. It means out of 3 counters, 1 number has 9. Okay, so because 9 is having only 1 number, no? That's why either 0 counter or 1 counter. So 0 counter, it means there is no 9. So without 9, which is 9 over 10. How 9 over 10? Can we understand this? 9 over 10, how we got that? Because there are 3 counters, right? Out of 3 counters, 9 over 10. So 1 counter with number 9. So there are total 10 counters, 6 counters with number 7 on it. So 6 counters, 7, 7, 7, 7, 7, 7. And 3 counters with number 8. 8, 8, 8. And 1 counter is 9. Okay. So this is 1 and total was 10. So 1 by 10. 1 by 10 for the 9. So not like without 9 is this 9 by 10. Okay, one number you have taken, then 8 by 9, then 7 by 8. Now 1 out of 3 counters has number 9. So maybe first time you can draw 9. So 1 by 10, then second you will draw 9 by 9, and then you will draw 8 by 8, I believe. Yeah. 1 by 10, 9 by 9, 8 by 8. Similarly 9 by 10, 1 by 9, 8 by 8. And here 9 by 10, 10, 8 by 9, and then 1 by 8. So 3 by 10 here. So y equals r. R is 0, 1, and the associated probability is 7 by 10 and 3 by 10. Now next question says variance. So mean and variance is simple. Mean is NP, and the variance is NPQ. Okay. 9 is available, so this is probability is 3 by 10 here when 9 is available. So what we need to find? We need to find the random variable y represents number of these 20 samples that contain the counter with number 9 on it. Find the mean of y and variance of y. Okay, the probability that number 9 is available, that is p 3 by 10 and 20 3 by 10. N is 20, p is 3 by 10. So NP is the mean and variance is NPQ. Now B part says a random sample of 3 counters is chosen from the bag without replacement. A random sample of 3 counters is chosen from the bag without replacement. A list all possible samples where the median of numbers on 3 counter is 7, so 7 should be in the middle, and you are drawing 3 counters. So maybe 777 first, 787, 778, 779, 877, 797, 977. These are the numbers, and if you arrange them in increasing order, so that median is 7, so like you have to just arrange them, but make sure 7 should be in the middle. So this one now 778, this one 778, 778 again, because from here, okay, from here. Now 779 from here, we already used this. Here also we can write 778, and here also we can write 779, and here also we can write 779. So in this, what was the question? Question was, list all possible samples where the median of numbers on 3 counter is 7. Okay, list all possible samples where the median of numbers on 3 counter is 7. So yeah, these are the numbers, but because if you arrange them in increasing order, then 7 will come in the middle. Okay, now C part says find the sampling distribution of median of the number on 3 counters. Okay, find the sampling distribution of median. Okay, so let M be the median of selected any 3 counters, but can have value either 7 or 8. In the middle, what can be there? 7 and 8. Let M be the median of selected any 3 counters, but can have value either 7 or 8. So M is 7 or M is 8. When M is 7, so 6 by 10, 5 by 9, 4 by 8. And here 6 by 10, 5 by 9, 3 by 8 times 3. And 6 by 10, 5 by 9, 1 by 8 times 3. That is 2 by 3. And when you take median 8, then 1 minus this, which is 1 by 3. And finally, this is your probability distribution table. Right, after that it is a formula sheet which I have added over here to use and to solve this question. So I believe you understood this full statistics S2 for Edexcel, and this was just, it was not for learning point of view. I clarified in the beginning, it is just for the revision point of view. So in 1 hour, almost 18 minutes, we have covered full statistics, theory as well as 1 past paper. So I believe you understood something, and if you really understand a little bit, like 5% also you understood, then please like and share with your friends, and at least like. And if you want to give some suggestion, then you can write in chat. Please make sure it should be positive and good feedback, and if there is something, then write some polite words so that I can improve and I can do better in the next videos. Okay guys, thank you very much, and wish you all the best for your exams. Thank you.